So the question that we're looking at now is, how might I use a single array to implement 3 stacks? Sounds like a pretty tricky question, but maybe it's not so tricky. Let's write it down and see. Let's do a little bit of drawing. Everyone likes to draw, right? Alright. I'm a very visual person, so I actually like to see these things when I'm thinking about it. So here's our array. Let's give ourselves a couple of segments so that we're able to work with this array. And we want to implement 3 stacks from our array. How can we implement 3 stacks? Single array, 3 stacks. First thing that comes to mind is to use the array like this. To hold our elements. It's pretty tricky though. There's so many problems we face. How do we avoid, for example, how do we avoid running into the rest of the array for one of our stacks? That's how can we keep, size is just a problem in general, the fact that we're limited by the size of the array to begin with. What does it mean? Stacks are pretty much able to grow to an undetermined length, and arrays are constant length. So that's a big problem we have to take into consideration, because if it were to happen that our stack reached its maximum capacity based on the array size, then we would have to copy everything over to a new array. And if we have 3 stacks in here, I don't even know what kind of a mess we would need to code up in order to copy these things over to an array. So, and where would our 3rd stack even be located? 3 stacks. Alright, well, let's do a little bit more drawing. Let's say this is our stack. This is our stack here. Initially, let's say we have the element, let's call it E1. Could hold E1 here, E2, E2. E3, 3 is in here. Well, now that I look at that, that may actually be a pretty good way to use our array to hold all of our elements. That might be a good approach, actually. So, multiples would be pretty good to work with here. Well, let's start over a little bit, just a little bit. Erase this stuff and this stuff and this stuff here. So the idea then is we have 3 stacks. Well, clean that up a little bit. Keep ourselves organized. All right. So then, what if we were to do it like this? E1 would be in the first location, in the first memory location of the array. Now, we'll call this, so this is stack 1, stack 2, and stack 3. And then perhaps we can call this element 1 for the stack, 1 for the element. And then this would be element 2 for the stack, 1 for the element, and element 3 for the stack, 1 for the element. So what we have here is E11, E21, and E31. And then E12, E22, and E23. Sorry, E32. Accordingly, you would have E2, E12, E22, and E23. So we've already encountered the problem where we've run out of space. And we have to think of how to address that. Most likely by making a new array, copying everything over. And we should probably make our array sizes multiples of 3. Or I think this will help us avoid doing too many copies. If the array is a multiple of 3, and we were in a position where, let's say, for example, if it were in a multiple of 3, as soon as we had this, we'd have to grow the array. Essentially, the idea being that our data will probably be fairly similar size, whatever data we're holding. All 3 of these stacks might be fairly similarly sized, although that's just assumption and may not be the case. In fact, we might end up with a situation where we have tons of data here. This actually could cause a big problem, because now we're expecting that we have an array that contains of this size. Then if we were at 3 more to the size of the array, we'd also be expecting to have hold this. Meanwhile, these are still empty. Essentially, we have E13, E12, and we have all of these empty spots in our array. And we could end up with a lot of empty, unused space and big arrays merely from having one stack that's very large. So how can we address this problem? Perhaps we might want to use a different implementation. It's very, very tricky for certain. What kinds of options do we have available to us? This is E14.